What is statistics then, I guess, is the first question. So the actual subject matter of stats itself. Some definitions. A datum, a single quantity. So actually datum is the singular. You very rarely see the word used because, of course, we more often see the word data, which is the plural. Okay, so one piece of data is a datum. It's the singular. And in stats, we represent that by random variables. So what is a random variable? A random variable is a function. Now the value of that function is determined by the probability, and this is where the crossover comes from probability to statistics. Random variables, you can have numeric ones or categorical ones. Now, you can also have continuous random variables, and that's if all the range of data is an infinite set of real numbers. Whereas discrete is where you could physically count the number of different options that you could have. So what's an example? Something continuous might be, although you could dispute this one, but it might be a person's height. Now, theoretically, that could range all the way from 0 to, I don't know, what's the tallest person in the world? 6 foot something, or they might even be taller than that. But theoretically, you could have every possible thing in between the two. Discrete is where you could physically count them. So if instead of that we said, shoe size. And shoe size is not continuous. You have size 4 feet and size 5 feet. Well, you have 4.5 as well, but they're discrete. You could physically count all the different ones that you've got. So we're concerned with descriptive stats. And that's probably what we're most familiar with at this stage, which just involves the collecting of the data, then presenting it and summarising what the data is. But then the most important part of stats really is this, the inferential stats. That's once you've got that data, is making some sort of prediction. You use it for some reason. So let's look at descriptive stats. We're going to summarise the data. Those summaries, visual, tables, graphs, charts, put all the data in there. Or it might be quantitative, mean, median, mode. So if we have univariate data, then we can find things like the measure of central tendency, mean, median and mode. Where's the middle of the data? And how spread out it is. That's usually the other thing we're interested in. Variance, standard deviation, interquartile range, those sorts of things. Bivariate data is when we talk about things like correlation. Are the two pieces of data related to each other? And then lines of best fit come in handy and things like that. Okay, let's have a look at our visual summaries. Frequency tables. Now, it's possible to put both numerical and categorical data into a frequency table. But with numerical, you can also put in a cumulative frequency table. Here's an example. Class of 20 students. How many pets they own. And there's the results of our 20 students. Okay, tally is probably one of the first ways we saw of how to fill out a frequency table. We would have done something like this. But of course, once we get to 5, whoop, put a line through it. And that's probably the first way we started recording. And then we transferred that over to a frequency. Contingency tables. They're great when you got something like this. Data's being collected, so this is bivariate data here. Because we're looking at a person's eye colour, but also what gender they are as well. So we want to determine whether being male and having green eyes are independent. Now, if you remember our formula for conditional probability, we found out that, hey, A and B are independent if the probability of A given B is equal to just the probability of A. So in this sort of table, I can say, well, I can look at this and I can see the probability of male is 82 out of the 167. But the probability they're male and they have green eyes. So now I'm only looking at the green-eyed people and 20 out of 35. Well, that's not equal to the probability of male. So that would suggest that being male and having green eyes are not actually independent of each other. So there must be some sort of link between the two. Different graphs and charts we've seen over the years. Of course, line graphs is going back to our number of pets example there. That will be it in a line graph. There is a column graph. A pie chart, also known as a sector graph. Bar chart, column graph on its side. Dot plot. They're all different ones that we've seen over the years. You might not have seen one of these though. What's called a Pareto chart. They're great for working out things like this. So frequency of defects as well as looking at the cumulative impact. So you basically got two graphs on the one. A frequency histogram, but you arrange it in descending order, and a cumulative frequency polygon. So here's my data. And this is for, we're producing a shirt. And the number of defects where, okay, in this shirt, there's something wrong with the button, and in this one, there's something wrong with the pocket, and another one, the cuff, and like this one, something wrong with the sleeve at the moment. There's the Pareto chart for it. So you'll notice that the frequency histogram is in descending order. So button had the highest frequency, it's gone first. Pocket, the next one, it's gone second, and so on and so on. But then we've also got the cumulative frequency polygon. Now, there's different scales. On the left is frequency, so that's for our histogram here. But on the right-hand side is the cumulative frequency percentage, and that's for our blue line there. And that's what we call a Pareto chart. So we could use that. For instance, well, if we wanted to fix up our shirts, I'm not necessarily going to focus on all 5 things, but if I just focused on the button and pockets, then that will get rid of 66% of all the defects. So we're sort of combining the two and coming up with that conclusion that maybe let's just focus on these 2 things, get them right, and at least the quality of our shirts will be a bit better. Quantitative summaries. So central tendency, where's the middle of the data? That's something we're always interested in. Mode, well, back to our pet example, we would have seen that one pet was the mode. That was the most frequent one. Doesn't necessarily have to be unique. You can have more than one mode. You might have bimodal, 2 scores. Trimodal, 3 scores. After that, we just usually say it's multimodal if it's got more than 3. Median, well, we're interested in the middle. The median is the actual middle. So for an odd number of scores though, that's brilliant because you can work out the middle. If you've got an even number of scores, you get the 2 that are in the middle and average them out, and that becomes your median. But the important thing is, you've got to arrange it in ascending order when you're working this out. So back to our pets, the median would end up being the average of the 10th and the 11th because we've got 20 scores all up. So if I break it in half, I'll have 10 on one side, 10 on the other. So I average the 10th and the 11th score. So 1.5 pets. A measure of spread then. So range is probably the simplest measure of spread. Highest minus the lowest. But only numeric data will have a range. I mean, you can't find the average of colours, for instance. In our example, 4 pets is the range. Okay.